We now talk about LRC series circuit. So consider inductor, resistor and a capacitor in series. So current is same everywhere in the circuit. So you can see this is a circuit and the current is everywhere the same in the circuit. But the voltage will lag current in a capacitor, it will lead in an inductor and will be at the same phase in the resistor. So this we have already seen before. So by the Kirchhoff loop rule, the sum of voltages across the three has to equal the applied voltage. But we cannot add them directly because there is a phase difference. So we have to use something called a phasor diagram. So again we want to use Kirchhoff loop rule. The sum of voltages across the three has to equal the applied voltage. But we have to use the phasor diagram because we cannot add these voltages directly since they are not in phase. So let us see this. So we see in the diagram that say the voltage for resistor is given here as V subscript R. So the current is in phase with this voltage. So the maximum current we will write down like this, I subscript M. So this is in phase with the voltage. But current lags behind, this maximum current lags behind the voltage in the inductor. So the current Im is lagging behind this voltage VL by 90 degrees for the inductor. But this current also leads the voltage in the capacitor by 90 degrees. So this is the voltage for capacitor, and now you can see the current is leading this by 90 degrees. So this phasor diagram in which we have a voltage across resistor, we have voltage across capacitor and we have voltage across inductor. So this we will use to determine the phase. So we will use the phasor diagram to determine the maximum voltage. So this will be the maximum voltage. So again we will have this voltage across resistance here, and now this vector is nothing but VL minus VC. Now we can see that this vector Vm is sum of these two vectors, VL minus VC and VR. So this is what this voltage vector is, and therefore the length of this vector by the Pythagoras theorem, this is hypotenuse and these other two are sides of a right angle triangle, or the length of this vector is nothing but VR square plus VL minus VC square. Now we can write these voltages here also. So this is VL, this is VR and this is V subscript C. So now you have this as Vm, and now you start substituting the values. So voltage across resistance is Im times R, where Im is the maximum current. Similarly, we plug in for VL and VC. You take Im out and then you get square root of R square plus XL minus XC square, and then you can solve for Im, and you denote this denominator by Z. So you get Vm by Z as the maximum current is equal to maximum voltage divided by Z. This Z is called impedance of the circuit, and again this has units as ohms. Now the phase angle. So the phase angle, or the angle which this vector Vm will make with the x-axis, this is called the phase angle, or you can say Vm is making with the resistance or the voltage across the resistance. So this is nothing but tan phi is nothing but VL minus VC over VR. So that is tangent is equal to this perpendicular divided by the base. So you have VL minus VC over VR. So VL is nothing but Im times XL, VC is nothing but Im times XC. So you know that we are using XL and XC as resistance, and Im cancels out. So you just get, so all these IMs cancel out and we get XL minus XC over R. So when XL is greater than XC, the current lags voltage. So because this phi is positive, so the current lags the voltage. So this is the voltage now. So this is the voltage. So if phi is positive, the current is in this direction. So the current is lagging the voltage. Now if phi is negative, so phi is negative means that XL is less than XC. XL is less than XC. So that means this phi is negative. That means we will be somewhere here. So in this case, the current is leading the voltage. So current leads voltage, and we call the circuit as more reactive than inductive. When XL is equal to XC, the phase angle is 0 and the circuit is purely resistive. So that is, if this phi is 0, then obviously current and the voltage, they both match, and therefore there is no phase angle, and thus we say that the circuit is purely resistive.